Test, test, test. Okay. Good morning. How is everybody today? Doing well? Not bad? This is our second class, right? We've got one tomorrow as well? I think so? Yes. Good. Okay. So I think we should be able to work our way through the rest of the databasing material today, and perhaps we'll even get on to our next topic. I'm going to try to move through the material reasonably quickly. So, any questions, comments, concerns before we get started? Yes.
Appetizer.
Thank you. It's so long, and thanks for all the fish.
Oh, I did that.
Yeah, there we go. So, actually, it's so anyway. So last time, just to quickly recap, we talked about SQL injection attacks, why it's always, always, always necessary to use some kind of proper interface to splice strings into SQL queries, rather than just manually performing string concatenation to insert them, because that leaves you open to people inserting malicious characters into your SQL queries, which can result in loss of data, both in the I have had all my data deleted and oh, now hackers all have my data, both senses. Incidentally, just you've probably heard this before, but just briefly on the topic of password security, right? How many people use the same password for multiple things? Come on, admit it. I know I do. So here's the thing. Here's why getting into a password, hacking into some poorly secured website and getting a password associated with a username out of it. Lots and lots of websites will use not only common usernames but also common like people will tend to use the same password on multiple sites. They'll even tend to use the same username on multiple sites. So if you hacked one, you've basically got a bunch of credentials that you can check across a large number of different websites, which is why two-factor authentication, while it's definitely a pain in the ass, is that's why things have been moving more in the direction of two-factor authentication, right? It's like, oh, you've never logged in with this computer before. It's like, wow, you're checking what computer I'm logging in with? It's like, yes, because of this whole problem with passwords. So yeah. Cool. Do I want to make an announcement about this? Yeah, okay. So I'm not going to be teaching 1xC3 next semester. Probably some of you are thrilled to hear this, but no, I'm not going to be teaching 1xC3 next semester or anything next semester at this institution because I've been picked up by Mohawk College. Thank you. It's actually kind of a form of miracle. So.
Can you get paid more at Mohawk or something?
Oh, geez, yes. Yeah, no, I've got like a full-time permanent position at Mohawk College. So. Oh. I feel bad abandoning you guys, but again, I'm sure there are mixed feelings about it in the room. But yeah, so that's why the bow tie. So long and thanks for all the fish. you know, I'm of course seeing out the rest of the semester and everything, but yeah, so you'll have to have somebody else for 1XC3. If you're lucky, they'll use my course materials, though. If you're not lucky, they won't. I mean, maybe it depends on your perspective, because like, I make that course reasonably robust in terms of difficulty, and I've not seen anybody else who's taught it teach it to the same degree. But at the same time, the like robustness with which I teach that course is like necessary for subsequent courses that you take. So, you know, like there's a tendency to make things easier in first year, and then you just get screwed in second year. But
Is 1XC3 C?
it's C programming plus Unix. So the degree, like what the department wants for that course is for it to be split right down the middle, half of it Unix, half of it C programming. But what ends up happening is because programming languages courses are somewhat easy to teach, it tends to like be pretty C heavy with a tiny, like you can take the last 3 weeks and do Unix stuff with it, you know, kind of thing. But yeah, it's actually my favorite course. I had a lot of fun putting it together. But yeah, anyway, so I just wanted to let you know about that, because, you know, Thursday is going to be my last lecture at this institution. It's 2 MP3, so yeah, anyway. I've been teaching here as an instructor since 2019, so anyway, so forgive me if I'm a little bit of a sentimental old man. They're like, you're too young to be a sentimental old man. It's like, oh, thank you. What is he, giving himself compliments now? Anyway, actually a lot of people think I'm younger than I actually am, but anyway. So, tables, relationships between tables. So we have explored how to add things to tables. We should have a reasonable handle on that. So the question then becomes, why the heck are these things called relational databases? In order to really see how this comes out, we have to have more than one table going on, right? So remember that now in our video rental store example that we've been working through, we are interested in keeping a table not only of videos, but of customers and the number of active rentals that are currently active. We would have a table for both customers and for rentals. The rentals table primarily associates customers with movies with a few additional pieces of information, like when they rented it and when it's due. Right? So, for example, if we had I'm not going to have time to do out all of this data entry, so we're just going to have to do it from the slides. Consider the following customer table. Our schema is we have our unique customer ID, which is an integer, a name and an address, which are both text. In addition, we have the, wait, what? Why this seems like a, okay, moving on. So, in addition, we have a rentals table. The rentals table has a customer ID, a movie ID, a date rented, and a date due field. Integer, text, and text required. Or date, but it gets turned to string in Python, so good. If we do a select on the rentals table, we only get customer ID, not the customer's name. And if we select for movies in the rentals table, we only get the movie ID. It's, if you wanted to look up the names of the movies which are currently rented, for example, you would query this rentals table, and then you would have to manually cross-reference the movie IDs for each of the movies that are currently rented out to find their titles. This seems like a lot of work, and we want to do it more efficiently. We have what is called the join command, although it's not an explicit command. This is a join operation. So when we select, we can actually select from more than one table at once. Select star from rentals, comma, customers, and then we have a condition which filters the results. So when we print from multiple tables, what it's actually doing is it's taking the first table and concatenating it with every entry, like every entry in the first table gets concatenated with every entry in the second table. So the total number of entries that you have is the number of entries in the first table multiplied by the number of entries in the second, right? We then perform a filtering command to select only those entries where the customer ID and the rentals customer ID are the same number, right? So let me just see if I can find an example to give you guys. I said we wouldn't. I'm not going to do the data entries. That I can rely on, perhaps the Winters version. Where's our database? There we go. Did I not capitalize it? I did not. There we go. Well, can't use that then. Doesn't have a rental. It doesn't have a customers table for some reason. All right, let's try fall 2021. There we go. So this is what we have in terms of a customers table. You can see it's not quite the whole table. Movies, we have the following. And in rentals, we have the following. You can see I don't care when the movies were rented, and they can take forever for all I care. So, this is interesting, right? So if we select from multiple tables, you can see that for each entry, we have both entries in the rentals table which have been appended, right? So this is kind of like standard table multiplication, if it makes sense, right? If that makes sense. And it's even worse than that. If you throw even more tables in there, it does the same thing but for every customer, right? So, for example, Monty Python and the Holy Grail has 6 entries. 3 entries for the first entry in rentals and 3 for the second, and then for that, each of the 3 customers are lined up. So every one of these is a unique combination of all of the records in each of the tables, and all possible combinations have been represented. That's another way of thinking about it, combinatorially. So, the question then becomes, what does the filter do? So, let's say where movies.movie ID, why am I thinking that's spelled wrong? It's not. Is equal to rentals.movie ID. No such. Dot fields movies. I changed the naming convention slightly in this one so that it was easier to type. So, select star from movies rentals where movies.id is equal to rentals.mid or movie ID. We only get one, right? So there's only, of all of these possible combinations, there's only one where the rental movie ID is equal to the movie ID, and that's the one. This is the only one, right? Although there are two entries in the movies table, or sorry, in the rentals table, there it is. This movie ID 5022 doesn't actually exist in the movies table, so it's not included, right? So there we go. In addition to this, if you want, you can only see like certain fields. So select movies.title, movies.rating, and rentals dot whatever the field was named, date due. And then you can narrow this down to just those fields of interest. You can see, perhaps, from this example, how being able to narrow it down to the fields of interest is something that you definitely have to do once the tables start getting sufficiently large. Right? Any questions about this? No? Okay.
I'm not sure, our comments and what's it mean by it's getting shorter and shorter?
What's getting shorter?
Up here it's just after our movies have ID and stuff MID.
Yes, so up here I'm viewing three tables at once, not two, first of all. Second of all, the where clause here, where movies.id is equal to rentals.movieid, this will select, it's just like a regular filter, right? It will select for display only the case where that condition holds. So because in the case of movie 404, in the rentals table, we have movie 5022 and 104, right? 5022 has no corresponding entry inside the movies table, so it's not displayed. 104 does. It's this movie here, Field of Dreams, right? So that's why that one is displayed. Does that answer your question? Cool. Any other questions? Good. So, the result is so when we select multiple things, the result is as if we had a single table with rows from each table joined together when they match on the customer ID field. Uh-oh. I did manage to convince that guy we need a whiteboard in here at least, you know? Oh, the chalk dust is breaking the circuits. It's like, yeah, well, know your place, mechanics, not like mechanical objects, It's like chalk is primal in the classroom. Everything, why wouldn't they get motors that prevent chalk dust getting into them, what it is it's like everything in modern society, it's trying to hammer a square peg into a round hole, But anyway, so Obviously, you can join more than one table if you want to display, from rentals, customers, and movies all at once. You simply combine multiple clauses in the filter condition. So, operations quick fire round. We have a few more operations to discuss, and then we will be finished with databases. So, we can update fields in more than one row using an update command. You may have noticed that up to now, we haven't really talked about a way to undo a mistake. If you make a mistake, there's really no way to undo it so far. The update instruction allows you to update a particular table, set some field to a value, some other field to another value if you like, but it's very, very important that you have the where condition in there. If you don't have the where condition, it will apply this globally to all records, which essentially means that it will remove any useful information that may have been contained in any of the records, right? So you always, 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 always must include the filter to target only those records you wish to be updated. Yes?
Is there any easiest way to undo it? Just in case if you make some mistakes?
It depends on the vendor. Some have an undo function, some do not. SQLite 3 does not. Any other questions? So, yes. So this is setting the genre and rating of Monsters Incorporated to horror rated R, which is kind of funny because, you could definitely think of a horror version of that story, So, again, have to be careful. If we omit the where condition, the update applies to every row in the table. So, the slides claim that there are no undo functions inside of SQL databases, period, exclamation mark. Again, this is vendor dependent. This is true in SQLite 3, but, being able, it depends on how they want to handle it. Having an undo command specifically, you might not have one, but you might be able to, you probably would have some kind of commit rollback sort of structure, kind of like a Git repository, where you would be able to restore the database back to previous checkpoints, right? It depends on a lot of stuff. Yes?
Wouldn't that, in industry, kind of be essential? People make mistakes.
Oh, yes.
Regularly, so I feel like a business where you have all your company's information on the table you want.
Yeah, if any dumb schmuck that you hired for data entry was able to completely destroy all of your company's records and database and just blow out the database, that wouldn't be an ideal scenario for the continuation of your business, let's say. Because corporate espionage and stuff totally does happen, this is just trying to scare you into, being sure you do things properly the first time. Because, while it's, certainly the ability to recover is a necessary part, and backups are necessary. If you perform a bad query in SQL, repairing it might take you more time and energy than you would have liked. You can't just hit backspace, right? So, you have to formulate a query which fixes the previous query, or you have to interface with the repo system. You have to do something that's a pain in the ass to fix problems like this although the problem can be fixed, you know, it's not always as simple as just, oh, I misspelled the word, let me hit backspace, right? So just, you know, you should formulate SQL queries with the same time and attention to detail that you would write any kind of programming code, in the understanding that a bug in an SQL query can cause problems, right? I think that's a fair explanation. Yeah. So, delete. So we can also remove rows from a table. Basically, the same cautionary tale applies. Delete will delete all of the records which match the filter condition. So the safest thing to do, of course, would be to delete by individual identification numbers, since identification numbers must be unique. Isn't it convenient to have identification numbers? But, you know, whatever Boolean condition you want to throw in there, it will delete them by it. If you leave it off, it will just delete every entry in the table, which is, you know, only one step removed from deleting the table itself. This is how you delete the table itself. Drop table name. Right? So, again, be cautious with this kind of stuff, right? This is the nuclear option. Make sense? So, any questions? Good. So the rest of this is basically setting up the SQL injection attack stuff. So that's databases. Any questions about databases? Are you all sufficiently bored? No? Okay. Let me put it to you this way. Recently I've been sort of introducing myself to web development, which is kind of something I've not really touched on much in my career. I've not really had any reason to so far, because I'm like, by training, I'm a roboticist. So, you know, but it's interesting, you know, because like many of these modern website architectures, like, it's like more often than not you'll have one of like an SQL database lurking somewhere in the back end, right? So even if you have a nice fancy schmancy ORM to interface between your software and the database, so you don't have to formulate so many of these queries automatically, and maybe they'll set up the tables for you and stuff like that. You still need to know, like, functionally how these things work, right, in order to be able to use the systems intelligently. Question?
Can you tell me which one acts as a placeholder? Like which part of the data?
The question mark. That's the placeholder. At least in Python. Other languages will probably do it other ways. Okay, good. Very good, very good, very good. All right, now I'm just going to pull one more set of slides on you. We're not going to leave class just yet. This is a short one, but we're going to talk about dates. I made a joke once. Back in like the early pandemic, when I actually cared, I was like naming the lectures, naming the YouTube videos, and it was like summer class, so it was like it lines up a lot better because like you get a 3-hour lecture, which is like a week, which is supposed to be a topic, so it lines up a lot better. But anyway, I named the video "How to Get Dates," and like it was like I'd opened the floodgates for all the Russian bots. It was amazing. Question?
Where can I find this link?
Oh, it'll be on Avenue under topic either 9.5 or 10.5, dates, date time objects, something like that. So if you want the secret to getting dates, just be yourself, because if you're not yourself, you won't have the stamina to lie for a long-term relationship. So it's the mental hygiene approach to just not lie to the person that you want to go out with to start with. You know, honesty is always the best policy. But anyway, so keeping dates inside of computers is a notoriously difficult problem. The measurement of time itself is a notoriously difficult scientific problem. In the medieval era, they used to have candles with like a little bit of gunpowder at intervals in the wax that would spark at what they thought were regular intervals as the fire sort of wore the wax down. You know, like early timekeeping technologies are like a fascinating little anthropological study. But these days, we are mostly operating under the Gregorian calendar. There are many complications involved in calendar systems. You have daylight savings time, which is a pain in the butt, as everybody knows, and I wish the government would just get rid of it because there's no reason for it. No good reason for it, anyway. Leap years and leap seconds. So, as you know, it turns out that the Earth is like very, very close to making a set number of rotations per orbit, but not quite. So, you know, every year they have to add a few leap seconds. This isn't actually so much a problem anymore now that everybody's clocks automatically synchronize to a centralized database. But, you know, in the past, people just didn't care that much about the time. You know, if you got the time to within 10 minutes, you were fine, probably. But, you know, so it goes. Time zones, as I'm sure everybody is aware, time zones are also a pain in the butt. Although, you know, arguably the most necessary, except maybe this one. Different and possibly ambiguous string representations of dates. Do you do year, month, day, big to small, small to big, month in front? That's the American way. So this is an interesting diagram. This is how dates are commonly stored in different regions of the planet. So you can see that these countries in yellow store things year, month, day, big to small. This cyan is day, month, year, small to big, which personally is my preference, actually. Green is either day, month, year, or year, month, day. So South Africa, and I'm not sure which one that is. Is that Kenya? Or I don't know. Forgive me, my African geography isn't fantastic. The U.S. is the only place in the world which does month, day, year, because that's how you say a date if you're saying it long form. So thank you, the U.S. And up here in Canada, it's common to see every form of date. That's what the dark gray means. So, and red is possibly, you know, due to U.S. influence, you sometimes see month, day, year. Otherwise, they have the, you know, the same sane cyan as the rest of the world. But yeah, so this poses a problem because if we are to program with dates, which you might imagine is a useful thing to be able to do, you have to account for the fact that when a user is inputting date information, depending on what part of the world that information is coming from, it could be in very, very different formats, which is just all kinds of dumb, you know? But then again, We still haven't been able to convince the US to get on the metric system either, so, so it goes. Even in Canada, colloquially, the imperial system is still used for a lot of stuff, if you weren't aware of this. In Canada, it's still quite common if you're talking about like the dimensions of a person to refer to that in imperial. Like your height is generally given in imperial and your weight is generally given in imperial. And construction is generally in an imperial as well. Probably because all of the parts are coming from the States and they're in imperial. It's like, we don't judge the width of screws by the millimeter. Let's put it that way, it's fractions of an inch. So, I talked to you guys about Unix epoch time, right? Yeah, cool. So, many of these sort of computer implementations of date, in the back end, they will be using Unix epoch time, maybe plus a component for milliseconds, right? However, you then have, somewhat similar to internet architecture, you have the data being stored in one form, but then the view of that data will be dependent on, what part of the world you're from, how you want that displayed to you, etc., etc. Although Python probably does it stupidly because Python is Python and Python is the worst. But, so, the date time class in Python, which you can import, is the representation in Python of dates and times, as you might expect. So datetime.date is a class representing dates in the Gregorian calendar system, year, month, day. Datetime.time is a class representing a time on an abstract day of 24 times 60 times 60 seconds. That gets broken into hour, minute, second, microsecond, and time zone. Datetime.datetime, anybody want to guess? Yes, date time is a date plus a time. Ooh. The one that is a little bit strange and off is datetime.time delta. So here's the problem, right? Let's imagine that you want to calculate the difference between two dates in days, right? What day does that fall on? Right? The question is meaningless. We don't talk about, if it's 3 days until the end of classes, we don't say, it's, January 7th, 1973 until the next class. We have a concept of an amount of time that's a difference between two other fixed points in time. That's what the time delta class is for. So when you add time to it, like if you are adding some amount of time to a date, you create a time delta object and add that, because it doesn't make any sense to add September 14th, 1973 to December 31st, 1812. It doesn't make sense, right? So we have a time delta class. This is your Python code for implementing such. From datetime, we import datetime. This import datetime line is so that we don't have to say datetime dot, right? We can just say datetime dot without the first one. So if we have right now being, actually we can do this in the interpreter. Why not? So date, time, import date, time. Oh my God. there we go, from date time, import date time, there we go. Date time dot now is just the current time as a date time object. You can see that the seconds tick up, right? Seconds are increasing. So, let's say exam is a date time object, 2022. What, it's 12th month. What day is it's the 19th, right? 19th at the 9th hour of the day, because it's at 9 a.m. Right? So, exam minus date time dot now. We have 12 days, 81,996 seconds until the exam. I hope everybody's using the time to study. Yeah. So yeah, so you can perform math on these things, right? Make sense? Any questions so far? Relatively straightforward, right? Good. What is less straightforward is how do we convert this to some kind of more human readable format, right? So we are, also concerned with being able to read things and viewing things as, fields inside of a datetime object is not going to make much sense to people who aren't programmers. We have the strf time, or string format time, function. The first argument is the only argument here is what's called a format string. Now, you'll get very, very used to these when you start doing C programming, right? Essentially, this percent sign indicates a slot in this string into which data will be placed. So we have a string with 6 slots. You can imagine, you can just from reading this kind of get a feel for what the various letters mean. But in addition to the percent sign indicating the slot, that there is a slot, the next character indicates what that slot is being used for, right? So in this manner, you can produce many different representations. So if we say, take this whole thing, call strf time on it, provide a string, there are d days, h hours, m minutes, and s seconds remaining until the exam are oh, they don't? What do you mean time delta doesn't have one? Well, that's dumb. All right, let me try this. Exam dot. Am I getting the word right? Weird. Well, anyway, I'll do it to just plain the exam then, since it's decided to be like this. Or just do it to datetime.now. There. So, obviously this is now no longer accurate, but you can see that it has taken the day, the hour, the minute, and the second, and it's inserted them into the string at the appropriate points. Good. So far, so good. You can even get interesting things like full names of what day it is. There's a whole big list of these. You know, weekday as locale's abbreviated name. So this is the locale's name. So you can see that, like, if you were in Germany, for example, you get the weekdays in German. We've got weekday as a decimal number, month as locale's full name. Just lots and lots and lots of options. 24-hour clock, 12-hour clock, etc., etc. Whether it's AM or PM, you know, all of this kind of interesting information. Question?
Isn't there a problem with Unix epoch time in that it's counting the number of seconds from 1970, but there's only 32 bits?
Yes.
Okay.
Yes! So in about 16 years, Unix epoch time runs out of space in the 32-bit integer that it's using to keep track of dates. Now, this is a different problem than the Y2K problem, right? The Y2K problem, you guys know Y2K, right? For a lot of you, this would have been before your time. But everybody thought that the world was going to end and planes were going to fall out of the sky because a lot of like date representations were going to, like, they were only actually using 2 digits to store the year because everybody assumed, I guess, that all computers would blow up sometime in the 90s. So there was this thing, people thought that the dates were going to, that everything was going to explode because of all the date problems, because they would wrap, basically when it hit 2000, it would actually wrap around to 1900. It turned out that the world didn't blow up, primarily because that was a software problem and could be patched, right? So there was this big thing to patch everything, and Y2K, the apocalypse, was avoided for a few years. In 16 years, however, approximately 16 years, Unix epoch time is going to run out of bits. And unfortunately, in a lot of devices, Unix epoch time is stored in hardware, not in software. So there are actually only 32 bits in hardware storing that number. So that's, well, you can't patch hardware, right? So harder to fix. Basically, it means that all electronic devices that use 32 bits to store Unix epoch time must be decommissioned in the next 16 years. Or else, they will wake up one morning. Actually, I think it's at about 2 in the afternoon. They're going to think suddenly that it's the year 1901. Yes?
So 64-bit computers would be fine?
Oh, if you added one more bit, it delays it by like 200 years. So if you add like 32 additional bits, then you're talking about an amount of time in seconds, and like, let's just say it won't matter anymore that they use, you know, when that number is reached, because the Earth will have been consumed by the sun by then. So there you go. Thank you very much, folks. We'll see you next time.